nuclear energy. Nuclear energy can be produced by means of, first, nuclear fission and nuclear fusions. What is the meaning of binding energy? Binding energy of a nucleus, EB, is the energy needed to separate all the nucleons to infinity. In order to separate the nucleon of a nucleus X into separate protons and neutrons, we have to use binding energy EB. By Einstein's mass-energy relationship, energy equal to mass times the square of the speed of light, E equal to mc square, we have the binding energy equal to Z times the mass of proton plus A minus Z times the mass of a neutron minus the mass of nucleus X. Then multiply the mass decrease by the square of the speed of light. Notice that 1 electron volt equal to 1.6 times 10 to the power negative 19 joules, and 1 atomic mass unit U is equivalent to 931 MeV. Example 1. For carbon-12, the binding energy EB needs to separate carbon into 6 protons and 6 neutrons. Hence, the binding energy EB equal to 6 times mass of a proton plus 6 of the mass of a neutron minus the mass of a carbon nucleus. Since the mass given are in atomic mass unit, therefore we multiply the mass decrease by 931 MeV. Therefore, binding energy of carbon-12 nucleus equal to 6 times 1.007276 plus 6 times 1.008665 minus 11.9967 times 931 MeV. The answer is 92.1 MeV. In order to compare the stability of different nuclei, the value of binding energy per nucleon, that is EB over A, where A is the mass number or number of nucleons in a nucleus, is used. Note that the greater the binding energy per nucleon, the more stable the nucleus is. Also, iron has the greatest value of binding energy per nucleon, which is about 8 MeV. Why do smaller nuclei tend to fuse together to form larger nuclei? The reason is that when smaller nuclei fuse together, a larger nuclei of greater binding energy per nucleon is produced, and energy is also released. In this case, the larger nuclei produced is more stable. Example of fusion is hydrogen 2 fused with hydrogen 3 together to produce a helium nucleus 4 with the emission of a neutron and energy. To explain nuclear fusions by the graph of binding energy per nucleon with mass number, when hydrogens 2 fuse together with hydrogen 3 the helium nucleus is produced. In this case, the helium nucleus has greater binding energy per nucleon, which means that it is more stable. Why do large nucleus tend to undergo fission process? The reason is that when a large nucleus undergoes fission, two smaller nuclei with greater binding energy per nucleon are produced, and the energy is also released. In this case, the smaller nuclei produced are more stable. An example of fission is uranium hit by a neutron undergo fissions and split into barium and captrons, which are smaller nuclei compared with uranium, and these two nucleus has greater binding energy per nucleon. Also, neutrons are emitted with the emission of energy too. To explain nuclear fission by the graph of binding energy per nucleon with mass number, when a uranium nucleus is hit by neutron, it undergo fissions and produce two smaller nuclei, barium and captron, which has greater binding energy per nucleon compared with that of uranium. Therefore, they are more stable. Let's look at the principle of the pressurized water reactor, PWR. Refer to the diagram. S is the concrete shielding. Which is used to prevent the leakage of radiations. R is the reactor core, which consists of 3 parts, F, W, and C. F is the fuel rocks, which are made of uranium, W is water, which has two functions. The first function is that the water acts as coolant, which removes the heat generated from fission reaction and transfers the heat to the heat exchanger. Also, the water can also be act as moderator, which are used to slow down the speed of the neutrons produced during fission so that the chain reactions can be sustained. C are control rocks made up of boron or cadmium, which are used to absorb neutrons. H is the heat exchanger. Water is drawn into the heat exchangers and absorbs the heat taken out from the water in the reactor core. Therefore, the water will be changed to steam. T represents the turbines, which is used to be driven to spin by the steam. G represents the generator. The turbines makes the generators to produce electricity. Let's look at the steps to generate electricity in a fission reactor. First, the slow neutrons split the uranium nuclei in the fuel rock and release energy. Water acts as coolant to absorb the heat released in fission. Since the pressure in the reactor core is very high, therefore hot water is still in liquid state. Next, the coolant together with radioactive substance such as barium and krypton go to the heat exchanger. And the cold water in the exchanger will absorb the heat from the hot water flowing in the reactor core and change it to steam. Then the steam makes the turbine to spin, which makes the generator to produce electricity. The whole energy changing process from nuclear energy change to heat energy, or we say internal energy of water and steam, and then to mechanical energy, or we say kinetic energy of turbines and generator, and finally convert to electrical energy. Let's look at some questions. What should be done in case of emergency, such as radiation leakage? In case of emergency, all the control rocks should be lowered or inserted into the reactor core to stop the fission rapidly, because control rocks will absorb all the neutrons produced. Therefore, no fission process can be continued. Which components in the reactor core will control the weight of nuclear energy released? In the reactor core, the control rocks will control the weight of nuclear energy produced. Because the weight of fission can be increased and decreased by raising and lowering the control rocks respectively, which will vary the number of neutrons inside. While the hot water in the reactor core cannot be used directly to turn the turbines, it is because the hot water in the reactor core are mixed up with radioactive substance, barium and krypton, which will emit radiation. Then, what are the roles of moderator, coolants, and control rocks in a nuclear reactor? The moderator, we use water, is used to lower the speed of neutrons produced in a fission so that chain reactions can be continued. The coolant, again, we use water, is used to remove or absorb the heat generated in fission. And the control rocks are used to absorb neutrons so as to control or adjust the weight of energy produced. Advantage, the pros of nuclear energy. First, low pollution, which means almost zero emission of greenhouse gases, such as carbon dioxide. Second, relatively low operating costs. And nuclear energy has high energy density. Disadvantage points of nuclear energy. First, high maintenance costs. Second, high risk in accidents such as leakage of radiation. Also, nuclear waste needs to be kept underground for a long time. Fossil fuels. What are fossil fuels? Fossil fuels include coal, oil, and natural gas. How do fossil fuels form? Fossil fuels are formed from organic substance of dead plants and animals over millions of years. What are the disadvantages of using fossil fuels, even though they are widely used? The burning of fossil fuels produces pollutants such as carbon dioxide and methane and sulfur dioxide. Carbon dioxide and methane are greenhouse gases, which will cause global warming, and sulfur dioxide will cause acid rains. How global warming is produced? First, solar energy penetrates the atmosphere. Next, the Earth's surface absorbs the sunlight and emits infrared radiation. The infrared is absorbed by the greenhouse gases in the atmosphere and radiate back to the Earth. Hence, the temperature of the Earth rises. Let's see the impact of extraction, conversion, distribution, and use of energy on environment and society. First, for extractions, fossil fuels is found in underground and seabed, which make deforestation and erosion. Also, wind power requires a large area of wind farm. Next, let's consider conversion process. Fossil fuels burning to produce air pollution, and wind power will produce sound pollution. For distribution of energy, electricity is transmitted by underground and overhead cables by using high voltage. The high voltage will produce strong electromagnetic field, which cause higher risk of getting cancer. For example, blood cancer. In terms of use of energy, all electrical appliances will produce heat. The heat released will increase the Earth's temperature, causing global warming.